Thank you for coming. So, challenge today is to build a service mesh using HAProxy and Consul, and we'll see how we made that happen. And let's go. Oh, not clicking. Sorry. Okay. Quick agenda will be introducing what is a service mesh from a definition point of view, how you can build it with Consul Connect, and then how HAProxy will integrate in the mix, and what would be the next step. So, basically, what is a service mesh? It's a dedicated infrastructure, so we took the definition from Wikipedia, but I think the definition from Lakshmi was more interesting. She said that it's separating the business logic from the network functions. So basically, you want your application to focus on business, and you don't want to manage anything related to infrastructure within your application. That said, your application may need to call other services, other whatever, database, etc. And because of that, you will need to access your network. But we'll see that the service mesh will help you fixing that. So that's the purpose of the service mesh. Service mesh itself, it's split in two layers. One layer is a control plane, and the other layer will be the data plane. So of course, as you may understand, that Consul would be the control plane and HAProxy will be the data plane. Main features of service mesh. So the most important is service discovery, of course, because your application has to reach out to other services, so it has to find out where those services are located. The idea is that you want it to be transparent, as much as transparent as possible. So service discovery means that your service mesh will maintain a list of endpoints available for this remote service you want to reach out, and it's going to allow you to get connected to that services. Load balancing, purpose of load balancing is to achieve high availability and to spread the load over your multiple nodes delivering a specific service. Encryption, this is when you want to cipher your traffic on the wire so you are sure that nobody can inspect it. It's quite important nowadays because more and more people are deploying their application on premise and or on multiple clouds. So as soon as you cross the internet, as soon as you are on an untrusted network, then you want to cipher everything outside your box. Routing, so we are speaking about HTTP routing. We are not speaking about layer 3 routing, BGP, etc. So the idea is that when you have services to services and some of your services don't really know where to find the other ones, they will speak to HAProxy, and HAProxy will say, oh, for this host header, for this URL path, for this whatever, I want to go to this service. That's what we call HTTP routing. Authentication is when you want to ensure who people are speaking, and you want to trust who they are, and you want to allow them to trust who you are. So we are going to see all of this in details. Authorization would be firewalling, like allowing or denying service-to-service discussion. And circuit breaking is the function which allows you to check if a service is available or not, take routing decision based on that, take another node in the same pool, etc., etc. So, from an infrastructure point of view, as we said, it's an infrastructure. So you will have two main components, well, three actually. One is your central service registry that will host your configuration. Then on each of your machines, so by machine I mean a box where you have an application, so that could be a VM, that could be a bare metal server, that could be a container, a pod in Kubernetes, etc. So your registry server will ensure the consistency of your global configuration, and it will also store your configuration, etc. Then you have the registry agent that will run inside your box or machine. The purpose of the agent is just to be a gateway between the sidecar proxy and the central server. It manages the configuration of the local proxy as well. So you will have to tell it what services it's supposed to access locally and what upstream services it's supposed to get connected to for the local service. And then we have the sidecar proxy. So the sidecar proxy is a software load balancer. It ensures that the ingress traffic is trusted and can reach the local service. And it also does service discovery, load balancing, etc. of the upstream services that this local service wants to get connected to. Now, what happens? So I have a client who wants to use my service A. That could be whatever. This client will get connected to an external IP that I called EIP, which is hosted by the sidecar proxy. So sidecar proxy will do what it has to do. We are going to define this a bit later. So mutual TLS authentication, etc. And if the traffic is allowed to come in, it's going to forward it to the local application node. If your application has to answer, it's going to answer back through the sidecar proxy. If your local application A wants to talk to service B, hosted on another pod, container, VM, whatever, then it's going to talk to the loopback where your sidecar proxy will be listening for the traffic. Then your sidecar proxy will get connected to the other sidecar proxy doing the mutual TLS authentication. And then the other service will allow the traffic to go into the local service as well. So service 1, service A could be Node.js application, service B could be Redis database, whatever you want. So advantages of the service mesh. First, as we said that we want to split business application from network functions, proxies are purposely written to manage network. So that's why the sidecar proxy would make sense in that part. If you were about to write your own network stack within your application, you may have problems, trust me. So yeah, the idea is that all your service-to-service communication will be very simple to make. You will just rely on the sidecar proxy that will do everything for you. Proxy will also come with built-in support functions for most of the requirements we see in the first slide. So HTTP routing, health checking, load balancing, etc., etc. And also, last point, which is very important, then you can let your application focus on your business and not on your network. Cons, there are a few cons. It could look complicated to set up. As we've seen sooner, as soon as we mention TLS, client certificates, etc., people sometimes get crazy. Oh, it's not going to work. I'm going to do insecure everywhere, like telnet, etc., allowing all that stuff. So it may be scary at the beginning. Another point is that you will have to inject a sidecar proxy plus controller, etc., within your machine managing your application. So it could be 2 other components to manage, to deploy, to monitor, etc., etc. So that's another problem. Some people say that service mesh allows you to do service-to-service communication without changing a single line of your code. So I would like to see that. In my case, it worked because I use, you can bind your DNS name to loopback and then to the loopback interface. Then in that case, it would work. But in some other cases, I'm pretty sure that there will be some problems. Now, we want to build a service mesh using Consul, and the module or the function from Consul to build a service mesh is named Connect. So what I like in Consul is that it's a Unix-like philosophy software. Do one thing, do it well. Well, one thing, it's more than one, but it focuses on service discovery, service registry. It has a simple GUI to see everything. The same binary can be used as well as a server and a client. And it can also embed a sidecar proxy. So, cool. And it's API driven, so we like it because we can integrate easily with it. Now, how authentication will work within Consul. So authentication, first, it's a question of trust. We want to ensure, services must be able to ensure that the service they are trying to reach is really the service it claims to be. And the server-side service wants to ensure that the client really belongs to the same organization that it. So if the mutual trust or authentication can't be done, then of course the connection will be denied and you won't be able to connect one service to another one. So this could be complicated. Consul will fix that for you. You can manage, or Consul will pre-build for you a dedicated CA, and it's going to generate the certificate for you. You can plug Consul with Vault, so you can have your own CA, and Consul will just use it and expose the certificate to the sidecar proxy. We'll see that a bit later. So authentication will happen mandatorily between the sidecar proxy. Okay? And you can also use authentication on the external IP. And we'll see later that we can do customize the configuration. So we can create multiple binds for the external traffic, some that would be untrusted, so no authentication, some that would be trusted with strong authentication with client certificates, etc. Of course, if you open a service on internet using that, you don't want to force all the internet users to have a certificate generated by your own CA. That's not doable. So that's for the authentication piece. The authorization piece, once again, is going to happen between the two sidecar proxies. So what will happen is that your service A proxy will get connected to your service B. Mutual authentication will happen. Everybody is happy with that. Then service B proxy will just take from the client certificate the SPIFE string. It's specially crafted X509 certificate, and we have a string with a service name, some kind of service ID, etc., etc. So your service B proxy will just take this one, send it to your local Consul node, and your local Consul node will return you 200 or 401 based on is service A allowed to talk to service B. For each incoming request, each incoming connection, this will happen, okay? Which means that if you change your rule, the next connection will be denied or will be allowed based on the changes you made on the rule. It's recommended, or we'll see that later. So the name in Consul is an intention, okay? We'll see that in the GUI right after. Then we have the proxy configuration. So, of course, since we must start up a sidecar proxy, we must providing to it some information on how it's supposed to get configured to load balance the local service. So the sidecar proxy will be given a proxy ID and a token. And when the sidecar proxy will query the Consul node, it's going to do it with the proxy ID, and then the local node will be able to deliver it the configuration it's supposed to execute. We also have access to the list of the upstream services. So remember on the previous diagram, we would have a list of, oh, this local service is supposed to get connected to service B. And on service B, this local service there is no list, so there is no upstream, so no configuration for that part. And then, of course, the local proxy will get access to the root certificate from your CA, and also the TLS certificate used by the local service. This TLS certificate will have two purposes: decipher or cipher the traffic with the client, so a server-side certificate, and a client-side certificate to get connected to the remote services. Because remember, in that client-side certificate, we have the SPIFE string that will be used to do the authorization part. So a quick deep dive if you want to do yourself a software that will use the Consul piece. So in the Consul API, you will have what we call the target service name. This is the name of the local service we are going to load balance, to give access to. So in my previous case, that would have been service A. You would have the local service address. This is the external IP address you want to use to expose this service to the other node. And this is this IP address that will be used by Consul in the node list for this particular service. You have a leaf certificate, as I said sooner. So this is called in Consul a leaf certificate. This is a famous certificate with a client and server side thing. Then we will have the bind address and bind port. This is where we are, no, sorry, I did a mistake. I think local service address is where HAProxy is supposed to route the traffic to find the local name. And bind address and bind port, this is where we are supposed to expose this service to the external other servers. Then we have the upstream. So the upstream is a list of, it's a list in Go. And it's a list of the services that this local service is supposed to get connected to. And for each upstream, we will have the IP port to bind locally. So for example, in my previous example, my Node.js server would find my Redis server on loopback 6379, for example, or whatever. So this will be provided there. And it will also call destination name into the API. So quick JSON piece that is describing my service A. So this is a Node.js server that is going to bind on the IP address 192 something on the port 8000. So if I get connected on the port 8000 and if I don't have the client certificate, HAProxy is going to deny me. So I will have to have the client certificate to get connected to it. Then we can see a list of upstream. So there is only one for now. And one of the upstream service is Redis. So service B in my previous diagram would be that Redis service. And we see the local port, local address where we want to bind to. There is no destination address because to find out where to get connected to that Redis service, it's simply a Redis service into Consul. So to know where you can get connected to, you have to go back to Consul API, say, oh, give me the endpoint or the nodes for the Redis service, get it, and you can route the traffic to that one. So Consul Connect, as I said sooner, will come with a built-in proxy. The advantage is that it's very simple to use. You don't need to install anything. It's already built in with your client. That said, it's not. I mean, its purpose is to be there, to be very simple to use, but there is no other feature inside. So basically, if you want to go in production with that, you can. But we'll see later that HAProxy has some advantages. Now. I guess some people here know already HAProxy and may wonder how we can make this happen. So here are the answers. So HAProxy, once again, it's also Unix philosophy by itself. It's a simple, I would say, load balancer, but which is very, very powerful actually. The more Unix philosophy kind of thing is I take two software which are dedicated and I make something very great with that, which is building our service mesh. So HAProxy, and I'm not HAProxy only because actually, as you may know, HAProxy is pretty static at runtime. We are making it more and more dynamic. But HAProxy itself won't be able to get connected to Consul to self-configure itself. So what we are going to do is to integrate Consul and HAProxy using a small Go binary that I wrote. And that Go binary actually will be the what I call the controller here. Okay. So the role of the controller, and maybe if you remember the JSON file was configured. Let me just go back to call a daemon whose name is HAProxy controller here. And of course, Consul won't manage HAProxy. Consul will manage the controller, and the controller will manage HAProxy itself. So how it works? What is the traffic flow now? Something a bit more fancy. So when a connection comes in on the external IP, if this is on the secured port, then HAProxy will do the TLS with the client, ensure that the client is trusted, etc. And then we'll take the spy phishing, and then we'll send a request to your local Consul agent to ensure that this client is allowed to get connected. If it's allowed, traffic forwarded to your Node.js application. Node.js application needs to talk to Redis. Whatever Redis is, it doesn't know, but it has to talk to it. Then Redis connection will be forwarded to your local HAProxy. Your local HAProxy will just, so in that case, the configuration will happen sooner. Your local HAProxy will just get connected to your remote HAProxy, mutual TLS authentication, everything is fine. Then your remote HAProxy will take the SPIFE string, so with www or whatever service name from service A, query that into your Consul agent locally. Your Consul agent will return 200.401. If that's 200, then HAProxy will allow it to go in. What happens at startup? So when everything is down, you will start up, and then you will have some kind of convergence. So your Consul server will just get all the services registered inside, and your HAProxy controller will also get connected to your local Consul agent, and will get the configuration from the Consul agent. Each time there is a change on the Consul agent, then the controller will also replicate the changes into the HAProxy configuration. And each time there is a change into your service, into your upstream, then the agent will also replicate these changes. So in Golang, this is translated into two SDK. So we use the Consul Client SDK or the Consul Agent SDK. We use it to get the information from Consul, and we use it as well in what we call the blocking mode. So blocking mode means that you have a hash corresponding or an index, depending on the piece you are monitoring, but you have let's say the hash. You have a hash corresponding to your current configuration. You can say to Consul, I want you to update me as soon as the configuration has changed from this hash. So basically, your request will be blocked by Consul until there is a change. And if a change occurs, you will get the new configuration with the new hash. Then you can apply the configuration, then open a new connection on Consul and say, hey, now I have a new hash, just update me when this hash has changed. And then we have the HAProxy Client SDK library. So at that point in time, you may ask, wow, where is it hosted on GitHub, etc.? Not yet. This is happening. So basically, it's still in beta by us, but it works already pretty well. The idea is that our client SDK allows you to manipulate HAProxy without even knowing what HAProxy is. What you want to do, for example, when you want to create an upstream, you want to create a backend, and then within that backend, you want to create servers, which are the nodes of your services. Just call these functions from our SDK, and the magic will happen for you. That's the same when you want to expose your local service on the external IP. Then you can use the create frontend, create a listener with the parameters you want, and the magic will happen. So part of this dev will be released in the community by the end of the year, and we are building as well what we call the HAProxy controller, or the engine controller, that will be a smart binary in Go. The code will be also released in Q1 next year. And the idea is that our controller will be aware if some changes can be applied on the fly. So we are going to apply them on the fly. And if some changes needs to reload HAProxy, then we are going to reload HAProxy. So all of this logic will be hidden for you, and you don't have to bother with it. Now we have to do the authorization. So the authorization in HAProxy will be done in Lua. So Lua allows you to execute your own code within HAProxy, and you can do a lot of things. If you are familiar with HAProxy, there is one thing that we call the HTTP requests, which allows you to create rules based on whatever happening. So what I do here is I have either an HTTP request or a TCP request based on the protocol being load balanced. So TCP when it's Redis, HTTP when it's Node.js or whatever other application. And this Lua code will just ask HAProxy, hey, forward me the TLS client certificate. And then from that, it's going to extract the SPIFE string. And then it's going to get connected to the Consul server, get the response with that corresponding to that SPIFE string, allowed or denied. If that's allow the connection in. If that's deny it. As simple as that. Now, are you familiar with that? I guess so. Otherwise, you would not be there. So this is a small Consul GUI extract from my wonderful service mesh I have in my laptop. So we see that we have the Consul server itself, we have a Redis service and a WoW service. Each time we create a sidecar proxy, then you will have a dedicated service called service name-proxy for this particular service. So we see the sidecar proxy for Redis and the sidecar proxy for WW, which is my W application. Now, in the Consul GUI, you also have what we call the intentions. So the intentions, remember, is that firewall rule set, which allows you to allow service-to-service talk. It's highly recommended to set your Consul policy to deny by default, because if you don't set it to deny by default, every service will be allowed to talk to every service, and then you will have to manage yourself intentions which says this to this, no, this to this, no, etc. Even if there are wildcards, it may be painful because each time you create a service, you have to create the intention. In my case, I don't care. I blocked everything by default, and I just open what I need to do all the time. That said, when you open everything by default, it's good for testing that everything is working, and we'll see that HAProxy will help you fixing that. So in my case, I have created an intention which says service WW is allowed to talk to service Redis. And basically, when the request comes in HAProxy, my Lua script is going to query my agent, my Consul agent, and the Consul agent will check the rule set and will say, oh, I have a rule which matches W to Redis, allow. Oh, it's time for the demo. Let's see. So I have on my laptop everything set up, and I hope it will work. Cool. So that's my service. Where is it? My service list. On the right, I have my wonderful curl command, which can be used to execute some HTTP GET. And everything is working properly, so I get connected to a specific port. You see that's the port 8002. If you remember in my JSON file, I said that 8000 would be the port that is secured. So if I go on port 8000 without my certificate, and I need to do SSL, I will be denied by HAProxy because I don't have the SSL client. HAProxy will log you something to say, hey, somebody came, TLS uncheck error, etc., etc. So let's go back to port 8002. So I still have a good answer. Here are my intentions. So I have an intention which says, oh, WW is allowed to talk to Redis. Nice. I want to break that. Save. OK. And now my Redis, my Node.js application is returning a 500. So what happened is that my Node.js application get connected to the local proxy. The local proxy get connected to the other proxy, TLS, authentication, etc. The other proxy said, hey, Consul, tell me if WW is allowed to talk to Redis. Obviously not. So my Node.js application just returned a 500 saying, well, I can't get connected to Redis. That's the point. We can also delete it, just to show you that it's important to have a denial by default. And of course, if I delete it, I see I'm still not allowed to make that happen. Just to ensure that it works, you just need to, so either we could say everything to Redis or W to Redis, up, allow, save, and we have fixed. Yeah, it's working again. Cool. That's a working demo. No. Oh, and this one is working as well. Everything is working today. OK. Oh, I forgot to show you the stats page of HAProxy, but that's fine anyway. So the idea is that for each sidecar running, we can have statistics exposed, etc., etc. And you would see that in your stats page from the WW service sidecar, you would have the WW service frontend and backend plus the Redis frontend and backend. And if you go to the Redis sidecar, HAProxy sidecar, then you would have a single frontend and backend for the Redis service itself. So I purposely took a TCP-based service because HAProxy is very famous for HTTP, but now you know it works as well on TCP, on raw TCP. Now, I said sooner that HAProxy would be better than Consul proxy itself. Why? So first, we can do layer 7 routing, which is not available in the built-in proxy. Second, we have the best, and that's not us saying it, that's a guy from Google who maintains this page. We have the best SSL TLS stack, so you will benefit from perfect forward secrecy, all that stuff outside of the box with HAProxy, with almost nothing to configure. From an observability point of view, HAProxy is very famous for reporting a lot of statistics that you can expose yourself into Prometheus, etc. It's also very famous for being very verbose at logging, and we'll see that in the next slide. And something also very important, HAProxy is battle tested. We think that most of the services you're using today have an HAProxy running somewhere. We can do rate limiting, we can enable a WAF, we can do a lot of things with HAProxy that you won't be able to do with the built-in proxy. And yes, something also which is interesting is that I did not have the time to make it happen, but HAProxy can use what we call an adjoint check that can be connected to the other proxy to get the pressure being done on the other proxy. And the other proxy could report to the upstream proxy, or to the downstream in that case, oh, I'm under pressure, just limit the number of concurrent connections to me, please. And we can do that as well. That would be for the V2 of the demo. Now, something, so the advantages. So I said sooner that we can be very verbose at logging. So we have 3 log lines. HAProxy will just do log everything. So we have the SPIFE string. So if one of your customers complains that, or if one of your service can't connect to another one, maybe the client certificate is not right, etc. So you will have the SPIFE string that you can check within your infrastructure to ensure that this is the right one. You will have status, whether it has been allowed or denied to get connected. All of this is issued from the HAProxy logs. You have all of this out of the box. And latest is the reason why the connection has been denied. So remember, I did 3 tests. One without any rules, one with a deny rule, one with an allow rule. The first line corresponds to the default behavior when my default ACL is denied. And this is what Consul reported us. The second one is when there was a deny rule purposely for WW to Redis. And once again, and you even have the rule number. And remember, in my GUI, I also have the rule number, so you can match it quite quickly. If there is something happening, you have an answer. I did a talk last week in Paris about HAProxy observability, and 1 hour was not enough to explain all the things we can do, so I won't be able to make it here. But we have a lot of things that will be useful for you. What's next? And this is the last slide. So I saw a lot of traction about, Consul Connect, something else. So I would like to see a Consul Connect HAProxy at some point. So of course, it's up to us to release our Go SDK. So this will happen later, hopefully, and we are going to work together with HashiCorp to make that happen. We want to configure telemetry as well. So we did not speak about that, but telemetry is a Prometheus piece. So it's available in the API, and we can make this happen as well. A more turnkey solution would be the Consul Connect, Consul HAProxy thing. And something that I did not show is what I liked in this solution. I give a try to Istio, and after 1 day of trying make it work, following step by step what is written on the GitHub account, I just said, well, okay, service mesh, we'll see later. And then I saw the announce of Consul, and since I know Consul is simple to deploy, I said, well, I will spend half a day as well on this one, and it worked. I first did an implementation using Bash to tell you that Bash plus curl can do exactly the same result. And it was very simple to set up. And what I liked as well is that you can put your own entries into the JSON file. So I did not show you that, but for example, for my Node.js application, I said, oh, you can enable the HTTP filtering mechanism within HAProxy because we know this protocol will be HTTP. For the Redis piece, I said, oh, I want HAProxy to run a layer 7 Redis check. And I said, oh, this application is pure TCP, don't enable the HTTP filtering, etc. You can do whatever you want, and then based on the keyword you put into your configuration, then you apply the relevant piece into your HAProxy. So one keyword could be, oh, enable WAF. Then in your template file, you can just put the configuration which enable WAF. And yes, so I think that's it, more or less. Yes, that's it. We are done.